Hello everyone, you're all welcome to another section of our lecture video on algebra, and today we are taking the unit 8, that is on permutations and combination. That is 2 more to go. Let's look at the intuition, the subunit where we will take from definition, differences, some formulas, and then some examples. Very quick one, and then we are done. I always want to have images in my slides, and it makes explaining concept easier. So let's look at the images I have in slide 3. You can see a save, ATM, award, and then an app. In the save, what do I need? In the save, I need some code to unlock it. If I mess up the code, this save will never open. In the ATM, I need my PIN code to continue transaction. Wrong PIN code, you get an error message, or to just do the right thing. In an award, I need first position, second position, and in that order. Third runner-up, second runner-up, first runner-up, in that order. In my KYC app, to access the app, I need my username and I need my password. You realize that there's something happening here. What is happening? There's arrangement of something in a particular order. So the order matters here, such that if you key in wrong username and wrong password, you will not get access to the app. If you give the wrong position to the right person, you've caused harm. If your PIN code does not work, there's no way you can withdraw your money. And so the order really matters. Okay, and that leads us to permutation. So I'll use perm or P, permutation. Arrangement order is important here. Now the second image has certain things. There's a lady in a closet, as we all do, to make a choice. We can spend an hour making a choice. So I can choose the red dress, the yellow dress, the white dress, the black bag to match up, or the brown bag to match up. I have a choice to make, so it's up to me and my mood swing. If I feel like being in red and jeans, I'm good. If I feel like being in white and jeans, I'm good to go. The second image have lecture sittings in the lecture room. It's still up to me and where I sit and my mood. So I want to concentrate, so I'm on the first 3 rows. So I want to misbehave, I just sit somewhere and then misbehave. If I go to a restaurant and I'm given a menu, it's up to me to select what I want to take, and my mood swings. I always want to add the mood swings. I feel like taking jollof. From jollof I'll take Sprite, from Sprite I'll take burger, from burger I'll take this. You're not obliged to say water first and cook first before the main deal. You can choose anything you want to do. And when it comes to cooking of meal, everyone has their own way of cooking jollof. I can have pepper first, tomato second, onion third, rice fourth. Someone has pepper first, tomato second, rice third, onion fourth. The end game is what we want. And so realize that in this second images, the order does not really matter. Because I have a choice to make, and that is what combination is all about. I can combine anything with no harm, so I use C. So this is the simple thing man to know about combination and permutation. We are arranging things, but the arrangement of things, one is in order, the other is not in order. And one is used for listing, so you want to list them, and one is used for grouping of things. That is the use of permutation and combination. Order matters, that is a key word you must note. Order matters, order does not matter for combination. I hope that has been well explained. Now let's look at the mathematical representations of this. There are 4 formulas here. I'll have 1a. P is for permutation, 1b. Now n here gives you the options you have on the menu, the options you have as an athlete, the options you have in a username. R gives you the choices you must make. I must choose white dress, I must do this, I must do that. So we are selecting something from an options we have. Okay, 1A means that the order matters, but there's a repetition. 1B means the order matters, but no repetition in your choices. Okay, let me say this is 2A and then 2B. 2A says, hey, do not worry about the order, but you can repeat the choices. 2B says, hey my friend, do not worry about the order, but do not repeat choices. Okay, and so this is how the formulas are being used. You must check whether the order matters and there's repetition. So it means we are looking at two things: the order and then whether there's a repetition or not, to choose from the formula. So I'll give you a simple example. Assuming you go to the bank and then there are 4 numbers to have a pin code made for you, and ask to select 3 numbers for your pin code. Here I have a repetition. I have a repetition of 1. I have a repetition of 4. There are still 3 numbers. Here they have unique, 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 and so on and so forth. Because it's a pin code, it means the order really matters. The order matters and means I have to use permutation, P. So in permutation, I can use this formula for when there's a repetition and this formula for when there is no repetition. What is N? N is 4. I have 4 numbers here and I have to choose 3, and so that is my R. And that is the use of the formulas. You must know when there's repetition and when there is no repetition. So let's quickly take examples here. Example 1, I'll use cases here. Case 1 is when the keywords are seen. When I say the keywords are seen, it means I see the word permutation, I see the word combination. So example, the number of combinations of 5 objects taken 2 at a time. I see the word combination, I see I have 5 choices, 5 options, sorry, and I have to take just 2 out of it. 5 objects taking 2 at a time. Is there repetition? No, it is not stated. So I would assume there is no repetition of my object taken, and that gives me 5 combination 2. Because there is no repetition, I use this formula, n minus r factorial, and this is 5 factorial. R is 2, n minus 5 is 3 factorial. And I can use my calculator to solve it and say you have 10 ways to select 2 out of the 5 objects. Example 2, I see a word permutation. I have 5 objects. I have 2 choices to make. And so I have 5 permutation 2. Is there any repetitions? Not really. So I have n factorial over n minus r all factorial because there are no repetitions. So 5 over 2, 3 factorial. And you can use a calculator to get these answers. Okay. Now, interesting case are when the keywords are not seen. When the keywords are not seen, how do I know I have to use permutation or combination? Example 1. We have some human beings. There are 6, and it says how many ways can they be paired up? So if you look at my write-up, I've used different colors to give different races. I can pair this and that. I can pair this to that. I can pair this to that. I can pair this guy to this black. I can pair this to the all black guy. I can pair this to this, this to this, this to this. You realize that the order does not really matter. I'm pairing, so the order does not matter. So I know I have combination. What is my n? N is 6 people. What is my choices? Pairing. Pair is 2. If you don't know pairing, pairing means 2 people. So 2, 6 here. Repetition it wasn't stated, so we assume there's no repetition. That is what you should always have in mind. And so I have 6 factorial, 2 factorial, 6 minus 2, all factorial. And you can use your calculator to have this figured out. So it says you have 15 possible ways to pair these people. Yeah, if you look at the intuition I have here, I said Faith and Mary are the same pair as Mary and Faith. So you have a choice to make. Nobody cares, and that is combination. Okay, now the second example, I have a contest and I want to award just the first and then the second runner-up. A contest, an award. So you ask yourself, does the order matters? Exactly, yes. If I swap position here, they are not the same. You can't say the first person is the same as the second person. No, the first winner is a first winner. If I swap it to this guy, they are not the same position. I have done something. So the order really matters when it comes to award. It's like your CWA, you don't want someone to get your score. No, so that is permutation. And so I have P. What is my N? I have 6 people in the contest. What is my choice to make? I have to award 2. Just the first and second position, not the third, not the fourth. So just 2 award. And that is 6 permutation 2. Repetitions, we will assume no repetition of positions. So 6 factorial, 2 factorial times 6 minus 2, all factorial. And then use your calculator to do this, and then you have 30 ways. This is n factorial over n minus r, all factorial, because there are no repetitions. So you have 30 ways to award the first and second position to these 6 contestants. Okay, example 3. In how many ways can a committee you want to form a committee? So this is what you want. This is what you want. You want to have 4 people in a committee, but what do you have? This is what you have. You have 3 men and you have 4 women. I've used the head for the women so you can see them. But you want 1 man and 3 women out of this committee. You have 4 men. So you ask yourself, does the order really matter? No. You can agree with me, the order does not matter, because I'm pairing. It's as if I'm pairing, I'm selecting to form a group. Groupings, there are certain keywords that should prompt you. I'm grouping, I'm forming a committee, so combination. But this is not straightforward, as you see, because in the first case I have 3 men but I want 1 man. In the second case I have 4 women but I want 3 women. So there is some summation of combination here. So n1 combination r1 plus n2 combination r2, that is 3 combination 1 plus 4 combination 3, and then you can find your answer. So if you are selecting 1 man out of 3 men, you have 3 ways of selecting them. And if you are selecting 3 women out of 4 women, you have 4 ways to do the selection, and that gives you a total of 7 to find your committee, to form that committee. This is practical in, let's say, forming groups in the classroom and so on and so forth. You use combination. Okay, unless some preference have to be made, then permutations comes in. Example 4, we are told there's a lab which has 10 scientists to work on project, but this project needs 4 in a team. We are forming a team. We are pairing some people up. Certain things should come to mind. Does the order really matter? No. So anytime you hear of groupings, combination should come to mind. We need 4, so it means My R is 4. I have 4 choices to make out of 10. I'm doing combination, and that is how simple this answer can be. When you solve this, you must get, so because it's combination, this is the formula I need. Again, we are assuming no repetition of person in forming the 4 group. This is even realistic. Yeah, I mean, one human being cannot be in repeat itself. Yeah, so that is it. I can't be in the same group twice. Like myself, I'm adding up to be 2. No, I can only appear 1 in each group. So that is it for the example 4. You always check the order and then you select your N and R. Example 5. I know most students hate to see these black balls and red balls because that is what we always used to. But don't worry, it's very simple. If you look at what I have on my write-up, I have black balls, 5 black balls, 3 red balls. I've used the color to describe them. It says you want, so this is what you have, and so that means that is your N. This is what you have, your N. But what do you want? You want to select 5. So this is what you want. It means this is your R part. You have to select 5 balls, not just any 5 balls, but there's a strict condition. At least 3 of them are black to form the 5. What does at least means? At least means that number or more. At most means that number or less. So greater than or equal to 3, but it should be within 5. So see, I can select 3 black balls, or 4 black balls, or 5 black balls. If I select 3 balls, because I want 5 in total, it means I have just 2 red balls to add up, 1 red ball to add up here, or no red ball to add up in this stage. Again, does the order matter? No. A big no. I can first select 5 all black, and it means I have no red to have. Or I can select 4 first and then select 1 red in addition. So I can select this first, this second, this third. Or I can have this first, this second, this third. The order does not matter. So I have 3 combination 2 plus 4 combination 1 plus 5 combination 0. And then by calculator, you can solve this thing. And that is it for permutations and combinations. Again, repetitions is not being stated here, so we assume there are no repetitions. Okay, now to the problem of the day. We have sequencing of DNA. Everybody has a DNA. And they're represented by some characters. If you don't know, you will want to read more about DNA sequencing. It says this DNA you see has distinct bases of 4 characters: A, T, G, and C. There's a key word here, distinct. It means there's no repetition. So sometimes you'll be wondering, should you always see no repetition or there's repetition? No. Some of the things are just there for you to know there are no repetitions, like the keyword distinct. How many distinct arrangements can be formed with these 4 bases? So I ask the question, does the order really matters? Yes or no? If it's yes, you know you are using permutation. If it is no, you know you are using combination. And because there is no repetition, if it's permutation without repetition, I have n factorial n minus r all factorial. If it is combination, I have n factorial r factorial n minus 1 n minus r all factorial. Which of these guys are we selecting? If it's permutation, good. If it's combination, good. You have reasons for your selection. And so go ahead and try this out, and let's have our answers sorted out. Thank you for your attention, and See you in the last two sections. Bye.